necessary to do that would flood into Woolworths at Smithfield. So I wanted him to calculate it to the specific shelf and walk in with a pair of flippers and goggle and snorkel and point to the shelf and say this is better. For some strange reason he wouldn't do that. It would be a great photo for his honours exit seminar. You know? Like, you know, did it get to the Tim Tam shelf? Or what shelf did it get to? You know?
Make it to the beer.
It's very important. Next time you walk into Woolies, far out. Big floods in the ground could come in here.
Sandbag around the liquor shop.
Why wouldn't all of you students would do that, wouldn't you? You walk in there, get your photo taken, point into the shelf for your exit seminar.
Photo review with the security guard.
You carry it in there, you quickly get changed, get in, point to it, get a photo, you're done.
Oh, nice. Just another observation. That area of the creek's a bit wider, but you obviously find these bigger boulders up there compared to down here.
You can do,
Yeah. Does that mean that you get a bigger, higher discharge through there? Or?
Well,
Is that because it slows down there and the bigger things drop out?
that could be, yep. Remember these are being dropped out too.
Yeah.
The other point I want to make to you is another phenomenon. See how we've got this, what we call a pool, just up here? Everyone take note of this and make sure you see it. Can you see where the water is just up here?
Yep.
Notice that's a feature. There's a pool there. We come up onto a bit of a rise here, and if you go down, you'll find more pools. There's a pool just down there near where the dead toad is. And so what we do is we go pools, what we call riffles, R-I-F-F-L-E-S, riffles, pool, riffle, pool, riffle. And the spacing of those pools and riffles tends to be 5 to 7 times the channel width. There's a lot of mathematical relationships in streams.
So is that down there a riffle?
We're standing on a riffle here. You actually get different flow velocities over pools compared to riffles. And it seems to be an inherent feature of streams that they'll produce this sort of thing in order to maximise the energy available to do geological work. So for the purposes of this subject, we need to think of streams as doing geological work. Of course, as I said, they've got many other roles, especially important ecological roles, habitat roles, etc., obviously, for aquatic species and planets. So,
Wouldn't the spacing change to the elevation of the slope of the actual river?
yeah,
Or is that what you mean by 5 to 7?
yeah, 5 to 7 times the channel width, they tend to be. I'm not sure how much detail Chris is going to go into with that, but there's a whole lot of stuff we can learn about what's going on there and why they form, etc., etc. Notice also that the stream, you know, it's got a bend here, and it tends to take a bit of a meandering shape. Okay, rivers also do that for very, very good reasons. It seems to be an inherent characteristic of moving fluid that they take a meandering shape. So if you pour a bit of water, so it forms a bead down a glass sheet, you'll notice that the water will tend to, it won't just go straight down, it'll go, notice how it does that? So water tends to meander, or fluids do. Air does it as well. Ocean currents tend to have these meandering loops in them. Air currents, winds do it too. The jet stream, for example, in the upper atmosphere, the upper part of the lower atmosphere, the troposphere, meanders. And when it meanders, it affects the weather. You notice how Darwin has had a lot of rain in the last few days, and there's a low moving out towards the Kimberley that might form into a cyclone. That's caused by what we call an equatorial Rossby wave, which is a meandering stream of air at high elevation, travelling from east to west. And it did a loop near Darwin, which started to form this convective instability, and a low developed from it.
Is that because it's all in 3D?
Yeah.
Rather than, you know, we look at things in 2D.
Yeah, no, definitely. Yeah.
They've got that depth to them.
Yeah. But that's meteorology. We won't go into that in too much detail. So, pools, riffles. You're sitting right in the middle of the riffle there, okay?
Lucky it's not raining.
Yeah, indeed. We could substitute you for Granny.
Good nickname, isn't it? Riffle. Hey, riffle.
There's a classic paper written by this guy called Farnstock. He was a geology professor in the United States, And he got his students out into a stream, I think it was called the White River or White Stream, I forget which state it was in, but it was a mountain-fed stream, and it was ice melt water. And he wanted to then, this was in the 1950s, right? So before we got a lot of these relationships between flow velocity and the size of gravels. So what he got his students to do is stand in the river and catch the gravels coming down, so that they could also measure the flow velocity and determine what was being transported at the time.
And you was allowed to talk to students.
Ice melt streams, that's right. So really, really cold. But those students got in there and did that for the sake of science. You guys wouldn't do it, would you? I want to do the same thing with cyclone surges and waves and the size of boulders being transported onto shore platforms along the coast and headlands.
We'll just stand here like this, catch boulders.
No, I think it would. I think that's a very silly idea to just stand there. I would chain you. You bolted
We don't want to be
to the cliff,
float away.
and you can catch it. And you go, oh, that one was really big. Good science, good experiments. It's unalienated learning. You know, you're involved in it. Yeah, good idea.
Yeah,
You just think I'm a mad professor, don't you? Yeah.
Riffles will do it.
Anyway, that's a true story about farm stock, and he did publish this paper with the students stood in there and look at those.
Did they get mentioned?
I don't think they did.
Yeah,
just basically the students. It might have been the class of 54 or something, but I don't know. But, yeah, they didn't.
Rest in peace.
Yeah. I've probably got pneumonia and suffering in old age now because of that stinking academic back then. Well, what else? I think that's probably going to be enough for today. Is that any questions or comments about anything? It's given you a lot of information here today, but you can see the advantage of being here, standing here, to understand it. So next week we're going to do the surveying. Okay, well, we'll learn to do the surveying. So next week's just a trial run. So please make sure you turn up, and please make sure that you learn how to do this. Don't be just one of the group, you know, that says, oh yeah, I think it sounds all right, or I'll get it off my friend over there or the other member of the group. Don't do that, because it doesn't work. I'm telling you out of experience, it just doesn't work unless you're absolutely involved and you know exactly what's going on. You won't get it. Okay? Don't rely on your friend to tell you.
Can I ask you about soil horizons?
Sorry?
Can I ask you about soil horizons?
You
Because
know.
we didn't do it in the field, we did it in the...
Okay.
Well, I didn't do it
In the
It's
lecture
close
field?
my-
Yeah.
Can you actually see soil horizons, you know, through here at all? They don't look very obvious to me.
No. Well, I don't know. I mean, to do it properly, we need the light in the right place. We need to clean up the face.
Okay.
Remember, soil horizons aren't always just defined by colour. They can be defined by texture and structure and other things as well. So sometimes they won't be visually obvious.
Okay.
As
Yeah,
well.
I was thinking that to be visually obvious.
Not necessarily. Often they are, yes, they are. And you can clearly see the A, B and C horizons. But not always. Not always. Sometimes...
I know that the distances vary greatly.
Oh, they do.
So
Yeah.
you can't just say A is always in the top 20 centimetres
No.
or something.
No, absolutely not. Now you can have very deep A horizons or very shallow ones, and likewise with B horizons too. Yeah, most definitely. But, okay, well, I think I've probably told you enough for today. So let's meet again next week, same time, same place. Baggy's back.